In this part, we show you on how we can solve the given problem previously, and what is the structured method to solve this particular problem. So this is some sort of the example on how your test will be. Means that it's more the design to be something like the open-ended solution. So basically, it's the way how you can think about this particular problem, and then how it can be solved part by part in terms of the arrangement, in terms of the hardware arrangement, in terms of the flowchart, and in terms of how the programming aspect. So basically, for this particular problem, so we have this type of problem. So let's try to solve this thing. First part is by using some sort of the hardware part first. So in this particular case, we have the Arduino connected with the servo motor, and then we have the Arduino input that was connected to the PIR sensor and also the serial port. So the hardware is a bit simple. So we have the Arduino, and then the output will be the servo motor, and then the input is PIR and also the serial COM. So basically, this is the hardware for the system. So we are solved in terms of the hardware part, the connection. We will do that thing in the tinkercad afterward. And then second part is the flow chart. So usually this is some of the way that we can make our programming much more easy by translating this particular problem into the flow chart so that we can do the programming easily. So basically, for this particular case, we have two sensors, the IR sensor and then serial port. So let's do the programming in a serial method. We can do that thing in the synchronous method, which is in parallel, but it will not be cover up for this particular problem. So let's think that we solve this thing in a serial way. Basically, the start, and then later on PIR sensor. So we solve for the PIR sensor part first. So PIR, let's say read. So if yes, then we execute some function. If no, then we look at the serial COM. So if we have some command, yes. So if no, then the process will be repeated. Okay. So now for the yes part, for the first part, which is for the PIR sensor. So for the PIR sensors, if any motion detected and then move servo 180, and then 2 seconds, and then servo 0, and then back to the start. So the servo for the pair is quite straightforward. So once any motion detected, then rotate servo 180 degree, wait for 2 seconds, and then rotate to 0 position, and then start the initial looping. So for the serial communication, so we need to receive the command and then extract the information. So first, let's say we say decode string. Decode string means that we extract the given command. So if let's say the decode If the decode is okay, then we execute some task. If no, then error, give the error, and then go back to the start. Okay, if the decode is success, then we check the servo command. So if servo command is okay, then we check the angle. If angle is okay, if no, then error start. So if servo is okay, if angle is okay, then only we rotate servo according to angle. So we rotate servo according to angle, and then once we rotate that thing, so it will go to the waiting for command, which is go to the start. Servo command, yes, angle, and then we have another command, which is the initial command. So if decode is okay, then servo command. If servo command is, if the command is servo, then we execute this thing. If no, okay, I think there must be some sort of another function here. Initial. If the command is not servo, or if the command is the initial, if no, then only we go to the start. This angle straight to error, and then to start. Initial no, if yes, then go to the initial, rotate servo 0, then go to start. Okay, so basically this is the flowchart of the whole structure of the programming. So the flowchart will be used to assist you in order to ensure that you can do the programming well in terms of the arrangement of the coding, what should be executed first, and then how we able to handle the error. So now let's get started to develop this particular application. So we will use the tinkercad. So the same thing, circuit, and then create a new circuit. So for this particular case, to make the things easy, so we will use the Arduino that already connected to the servo. So for this particular case, there will be one example of the Arduino that already connected to the servo. So we take this thing. So basically this is some example that the Arduino already connected to the servo. So the servo connection is quite straightforward. So for this particular case, we supply the power source to the servo, and then later on the signal will be connected. For this case is number 9, so means that this is the pin in Arduino that capable to generate the PWM. We refer back to our hardware, so means that we have the servo and also the PIR, and then also the serial command. Serial command is straightway. We use the one that is already in the Arduino, so we just need to add the PIR sensor for this particular case, we just add the PIR sensor. PIR. Okay, so we have here the PIR sensor. So let's put the PIR sensor somewhere in here. So the PIR sensor, the connection is almost the same with the servo, means that we have the ground, the power source, and also the signal. PIR sensor, if some motion detected, it will give the high signal. If not, then it will be low signal. It's something like the push button. So we just connect the PIR sensor straight away. So in this case, the ground to the grounding, then change the color to black, and then power source we can connect in the same connection with the motor. So in this case it will be red, and then finally the signal. So let's say the signal we connect to pin number 8. Okay, so pin number 9 will be connected to the servo, and then pin number 8 will be connected to the PIR input sensor. Okay, basically we have settled up in terms of the hardware. So now let's develop the software part. So just click the coding, then click the text. Basically this is the basic structures. If you run this coding, so the servo will be rotated. So this is based on the previous example, stock simulation. Okay, now we try to settle the part one by one first. So let's say we settle up the part for the PIR sensor first, and then later on we add the second part, which is for the serial communication. So we try to solve this part first, which is PIR detected, and then later on move the servo 180 and 0 to second, and then 0. So in general we can define PIR pin. In this case PIR pin is 8. So the next part is, so servo is already connected to pin 9, so it's already since we used the example, so everything was configured regarding the servo. So the next part is since the PIR will be act as the like a push button, so we need to give some sort of the input. So in this case pin mode, the PIR pin, and then in this case it will be input. And then the next part in terms of the state of the pin. Okay, so we just move the things here. So for the PIR pin, we need to define the PIR pin state. So since it will be something like the digital, so we can just write digital read PIR pin. So this is, we just read the state of PIR pin. Okay. So once we read the state of the PIR pin, so if any motion detected, then servo should be rotate according to this requirement, 180 degree, 0, and then 2 seconds. Okay. So we can just disable all this function. We just use the servo command straight away. Let's say I just take this servo and then put some condition statement. So the condition, if PIR pin state equal to, in this case, if it is high, it means that some motion detected, then we need to execute the listed command, the listed requirement. So for this particular case, is servo shall go to 180 degree. So let's say if we give the same delay, this is 15 millisecond, and then we need to wait 2 seconds. 50 seconds to execute the movement, and then it will go to 0 position, and then just keep the same delay. So in this case, it will go to 180 degree and then to 0. So let's try the simulation. So if some motion detected, so it's not really working for this case. So the reason why for this particular case is because of the delay. So the servo need to we need to give some time, some sort of the some delay to the servo to execute the process. So for this case, let's say I just put the delay is 1.5 1500. 1500 means that this is around 1.5 seconds. So let's just put once we start the system, the servo will go to the 0 position. So let's just look what will happen if we change the delay. So we give some motion. Okay, so means that if any motion detected, we go to 180 degree and then go back to the 0. So the same thing. Okay, so now we have complete this requirement, and then the requirement is that the servo need to wait 2 seconds before go back to the initial condition. So we start back the simulation, wait 2 seconds, and then go back to the 0 position. Okay, basically we have completed in terms of the first requirement, which is quite straightforward. So this part is completed. So the next part, we go to the second part. So this is a bit complicated since we need to do some sort of the decode the string, and then we need to test everything regarding the string first before we can execute the command. So the first one is it will be based on the given command here, servo everything, and then second part is that the initial command. So basically first thing first, we need to ensure that it will extract the information regarding the comma, or without the comma, it shall be the initial command. Okay, so we try to solve this thing part by part. So we try to solve the decode part first, this part, and then this part. So once this part is settled, then it's more on the individual aspect of the servo command. Okay, we go back to this particular part. So we need to define some string regarding the command, and then the string regarding the angle. So let's say just put here the notation. So we define as the global variable. So let's say this is the command and then angle. This is the string that we obtain, com string that we obtain, the raw string that we obtain from the third party. And then the second one is the command string, and then also the angle string. So command angle is the raw command that we receive from the serial input, and then later on this is after we perform the command detection, and then we separate the command, means that the command servo comma angle and the initial. So basically what we can do here, we can put maybe somewhere below here. So for this particular case, the first command, if you still remember, is we need to check whether if data available in the buffer. So we can do that thing by using if serial dot available higher than 0, means that we have some data, then only we can execute the serial dot read function. So for this particular case, we have the command angle. Command angle will be serial dot read string. So it will read all the given string. So let's say if we read the string, then we can just let's say just print the string first. Command angle. Okay, we can compile that thing first. So there will be some error. Serial available supposed to be the function. Okay, so we can load that thing, the function in the serial monitor. So let's say we send the servo with some angle, maybe 90 degree. So what will be appear? So in this case, nothing appear. Okay. Serial available hydra command angle serial dot read string. Okay, and then serial dot pm command dot angle. Okay, so this is the supposed to be the correct command. Serial dot available. Okay. Okay. Try compile. Initial, we send the initial command. Servo 70. Okay, still not appear. So we need to check for this particular part what is happening. So okay, so we don't have any setup for the serial. So for this particular case is serial dot begin. So this is the pretty standard baud rate. So we can try start the simulation, and then servo 90. Okay, So now we are settled. So means that so the serial able to read everything. Okay, so this one is settled. So the next part is the we need to detect the comma. So we can look at this example how the comma was detected. So for this particular case in terms of the string, the second part comma separated, so means that for this particular case the string dot index of, so detect the comma location, and then substring, so means that we can use these two command. The first one is index of, the second one is the substring. Okay, so uh, say I just put comma location in comma location. So in this case detect the comma location. So the comma location, okay, it's better that we detect the initial command first. So let's say if the command angle equal to initial or command angle same thing equal to initial with the I, or command angle with the whole thing in capital letter. Okay, then we can execute the initial command. So means that if if the command angle equal to the first command, so if that is the case, then we can just straight away put the command. So if this is the case, if a equal to initial, so then we can just straight away state that right 0, and then give some delay. So if this is the initial command. Okay, so for the second part, only we focus on the, let's say if not initial, then it's either can be the servo comma, so only that we detect the comma. So let's say the comma location will be the command angle dot index of. So the index of the, this part is the index of. So in this case we want to find the location with respect to the comma. So means that for this particular case we have the comma location. So the next part is to extract the substring. Okay, so in this case, if the comma location is not equal to -1, so means that we have the value of the comma location. If comma location is not -1, so what we can do is that we extract the substring. So we have the location of the comma, so that we can extract the information regarding the, if comma location is not equal to -1. So for this case we can extract the substring. So the substring will be the command. Command will be equal to command angle dot substring, you need to check is case sensitive, so means that you need to really look at so everything is small letter, so means that strng, so the starting position will be 0 and then the ending location will be the comma log. So this is the location of the command, and then secondly in terms of the angle, so the angle location will be the command.angle.substring. Only the location will be comma log +1, and then it will be based on the command angle dot length. Okay, so we can just put here first. We try to look at the stereo dot print line of what is the command, what is the angle. Okay, try to simulate first. Okay, so let's say we put the servo 90. So it's correct, servo and then 90. If we just put initial, then just put the initial. So you can see from here we're able to extract if we type the servo command. Let's say I just change servo 100, so it means that it will detect this is the raw string, this is the extracted individual string, means that servo and then 100. So we are settled. Then once everything is okay, so the next part is that we can execute the command of the servo. So in this case means that if everything is okay, so we need to check first in terms of the command. So if command equal to servo or command equal to servo with the bigger S, or command equal to servo with the whole capital letter. So means that so we able to detect the command angle. So if command angle is not detected, we can just set that wrong command. Okay, so means that the command is not servo. So if the command is the servo, so what we can do is that we can move the servo dot right. So in this case depending on the angle, so but we need to convert the angle to integer. So in this case convert to the integer means that will be, if I'm not mistaken, is to in, yes, to int okay, some function. So we can try simulate. Okay, can let's say type servo 90 degree. Oh sorry, we need to put some delay to execute the task. If not, then servo will not move accordingly. So we start simulate and then servo 90. Okay, servo rotate to 90 and then initial. Okay, it go back to the initial position. Let's say I just give the command of servo 45. So we move 45 degrees and then initial. Okay. So let's say if I put in the command, let's say it's not servo, maybe I just put test 90. So we give the wrong command. Okay, so it means that everything is fully function. So basically we have completed most of the tasks here. We have completed in terms of this task. Initial is okay, this part is okay. Then we're able to rotate the servo. So for this particular case only we left with this part, means that we need to check the value of the integer. So the value here. So if this part create the function to check the value of angle. So it must be integer only before execute the command. So means that we need to check this value must be let's say if I give some command, let's say servo, and then just put p here. So what will be happening? So nothing will happen. So we need to develop some sort of the checker for the angle part, so that it will detect the angle must be integer before it can execute the task. If not, then give some sort of the error command. So for that particular part, we need to create some function that the function can be located somewhere in here. So means that we have execute this thing. So before we able to execute this part, so we need to have some function here, function to check the angle must be integer. So I left this part for you to look at. So please find a way how you're able to check whether the value of angle is integer or not. If it is integer only, you will execute this part. If not, then give some error that stated that the error in terms of the angle is, you can if angle is integer, then execute command, else give error, wrong angle. Okay, so I left this part to you to do. So I will share later the whole structure here, and then please add this function. So this is your task for this week. So and then send to me the correct version after you put the function checker. So it must be something like the function. Let's say you check, you stated the function will be a check integer and then pass the value of angle, and then you need to create another function below here, so that the function will check the integer before it can give permission to run the servo. Okay, so that's your task for this week. Thank you.